This module is going to be on Introduction to Parallel Programming in OpenMP. Where do we use parallel computing? Scientific computing is one huge area where parallel computers are used. This is primarily to solve numerically intensive simulations. Parallel computing is used heavily in database operations and information systems. For instance, web-based services, they are made scalable. So there are so many requests coming into web servers these days, they have to be load balanced, they have to be sent to different servers. The computations have to be done in parallel. Web search engines, online transaction processing, right? Just imagine the number of requests, right? So all of them have to be done in parallel. Then there are other systems like client, inventory, database management systems, data mining, online transaction processing, MIS systems, and so on. Then another area is artificial intelligence, machine learning, and deep learning, right? So again, these areas are making heavy use of parallel computing. If you look at something like neural networks, right? So there are lots of nodes which are getting inputs, they're doing some computations, and then producing some new output, which is then consumed by other nodes, right? So it's a graph, layered graph, and lots of nodes are doing computations in parallel. So all of this, is very amenable to parallel computing. And then there are other areas like real-time systems and control applications where this is used heavily. So this is intended to be an introductory course in shared memory parallel programming, right? So we will be focusing on the shared memory aspects, okay? That is slightly simpler in the sense that, you can start off with a sequential program and you can incrementally convert it, introduce your OpenMP commands into that, directives into that, and make it run in parallel. And you don't require a huge infrastructure. You can do it on a node which has multiple cores. Even your laptops today have multi-cores, right? So you can, so it will be easy to work with that. So we'll focus on OpenMP, shared memory programming. So we will understand the concepts and programming principles involved in developing scalable parallel applications. We'll see how much we can scale. We'll try to scale up to 8 to 16 cores. And we'll use OpenMP and C to write the scalable programs for multi-core architectures. Okay, that's the plan. So this is going to be for both computer science and non-computer science students. I'm going to cover whatever basics of operating systems or architecture is required in this course. What is expected is that you have a reasonable understanding of C. You're reasonably comfortable with C.